Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically, we were discussing about the assumptions and the statistics, right? We had seen a little bit of things regarding the assumptions, that basically what assumption you should take and basically what you can perform and all those things, right? We had seen one condition as well. Now today we'll be proceeding on with this particular topic only. We'll be seeing all the assumptions which are here, right? So first of all, basically, let me just revise out that what we had actually done in the previous video, then I will be proceeding on here, right? So basically, we had seen that when you perform a hypothesis test of a single population mean, that was mu, right? We had given that symbol as mu. We denoted with the symbol mu, right? So, when you perform a hypothesis test of a single population mean mu using a student's t distribution, there are fundamental assumptions that need to be met in order for the test to work properly. So the assumptions which were basically there, that was that your data should be a simple random sample that comes from a population that is approximately normally distributed. You use the sample standard deviation to approximate the population standard deviation, right? This was that we had actually taken, right, that it should be normally distributed, and after that you use the same sample standard deviation to approximate the population standard deviation, right? Now basically we can just have a note here that whatever the sample size, basically if your sample size is sufficiently large, then the t-test will also work even if the population is not approximately normally distributed, right? So if your sample size is sufficiently large, so in that case your basically t-test is basically the concept which you are already studied, right? So t-test will actually work, it will even work if the population is not approximately normally distributed, right? As the other condition was that it need to be approximate normally distributed, right? But if your sample size is enough large, in that case this can even work as well. Okay, so this was the thing that we have discussed. Now basically I'll be proceeding on with some other things as well. So let me just take out a color from here, and right here I'll just come down first of all. So okay, right here I would be start writing. So it comes that right. So when you perform a hypothesis test, when you perform a hypothesis hypothesis test, when you perform a hypothesis test of a single population mean, of a single population mean. So basically, when you are performing a hypothesis test of a single population mean, that is mu, right? Mu is a symbol for that. So using a normal distribution, normal using a normal distribution, I would just write here distribution. So when you perform a hypothesis test of a single population mean, that is mu, using a normal distribution, so what we do, you actually take, so you take a simple random sample. You take a simple random sample, right? You take a simple random sample from the population, right? So we just take a simple random sample from the population, right? And I would just come down, and one more condition actually met here. So that is the sample, the population you are testing, the population you are testing. Okay, just let me write that clear. Right, yes, the population that you are testing is normally distributed. It is normally distributed. Right here it is normally distributed, and okay, or the second thing is that sample your sample size is sufficiently large, or your sample size is sufficiently large. This was the thing which I have mentioned above as well, right? When I was just telling you a note for that. So what I just mentioned, that if the sample size is sufficient large, then the t-test will work even if the population is not approximately normally distributed, right? So like related to that only, I have just written out the second thing here, right? Now basically what do we know? So you know you know the value of the population. Let me come down. First of all, so you know the value of the population standard and deviation, right? You know the value for the population standard deviation. Let me come above. First of all, let me take the scroller from here, right here. Fine. So my condition says that when you perform a hypothesis test of a single population mean mu using a normal distribution, you take a simple random sample from the population. The population you are testing is normally distributed or your sample size is sufficient large. You know the value of the population standard deviation, right? Second thing comes. Now this is the another thing that was above one was we have discussed about the hypothesis test of a single population mean. Now again we are just going to do that, but we are going to discuss about the hypothesis test of a single population proportion. Above was the mean, now is the proportion, right? So I will just add here that when you perform a hypothesis, right here. So when you perform a hypothesis test, of a single population proportion, here comes the proportion, right? So when you perform a hypothesis test of a single population proportion, that is P, denoted by P, right? You take a, what do you take? So you take a simple random sample. You take a simple random sample. You take a simple random sample from the population. This is what you do, right? You take a simple random sample from the population. Now, what is the condition that you must meet? So, you must meet the condition. You must meet the, let me come down. Right, you must meet the condition, that is basically condition for a binomial. You must meet the condition for a binomial distribution, right? So when this type of case actually comes, that when you are going to perform a hypothesis test of a single population proportion, then in that case you must meet the condition for the binomial distribution, which are there as a certain number of as a certain number of n of independent trials. Okay, this is the condition that you should meet, that independent trials. Now, what will the outcome of that? Comma, the outcome of any trial. You take any trial, okay? So the outcome of any trial are success and the failure, right? So outcome for the any trial are successes and failures. Let me come down. So the outcome for any trial are successes and failures, right? And each trial has the, okay, just one second, and each trial has the same probability of success, okay, of a SUCC, of a success, and that is actually P, right? So and each trial has the same probability of a success, that is P. Okay, this is the thing. Right, now basically let's define the shape as well of this. So the shape of the binomial distribution. So right here, distribution. So the shape of the binomial distribution needs to be now this needs to be similar to the shape of, it needs to be similar to the shape, it needs to be similar to the shape of the normal distribution. To the normal, okay, just let me erase this normal first of all and let me come down. So the binomial distribution needs to be similar to the shape of normal distribution. These are the conditions which should be met. Okay, normal distribution. Now, to ensure this, we have to ensure this particular things. To ensure this, we have the quantities NP and NQ. NP and NQ must both be greater than 5. Okay, this is the condition that I will just write here. NP should be greater than 5 and NQ should also be greater than 5 so as to get the shape of a normal distribution. So in that case, the quantities which are NP and the NQ. Okay, let me just write that Q above. I have missed that thing here, right here, and let me take the color. Okay, just 1 second. Let me take the similar color again which we were taking. So here goes the NQ right here. So to ensure the quantities NP and NQ, okay, both must be greater than 5. NP should be greater than 5 and NQ as well should be greater than 5. Right, then basically we have approximately the normal distribution. We have that mu is equal to P, comma, for sigma we have under root of P into Q upon N, right? This is the thing that we have. And what is the value for P? So P is equal to Q minus 1. Right, so these are the conditions, these are the assumptions which we actually need to make while defining the thing. Let me again take the scroller and tell you the last one which we have actually written here. So when you perform a hypothesis test of a single population proportion, that is P, you take a simple random sample from the population. You must meet the condition for a binomial distribution which are there as a certain number of n of independent trials. The outcome of any trial are success and failure, and each trial has the same probability of a success, that is P. Then the shape of the binomial distribution needs to be similar to the shape of normal distribution, and to ensure this thing, the quantities NP and NQ must be greater than 5, right? And here are the formulas which actually constitute these assumptions, right? So I hope I just made this thing very clear to you that how we take the assumptions, which assumptions to take at what particular place, right? So this is regarding the hypothesis test only, and I'll be moving towards some another topic in the next video, right? So this is all for this video. Till then, thank you and take care.